test the results. We don't know standard error. Alright. Sorry, I made a mistake. Yeah. For the model, for the arch models, we need to choose the variables DLDM multiply 100 as our variables. So the software will calculate the squared residuals by itself. So we do not have to estimate the residuals again and the residual squared residuals. For the squared residuals, we use the data to identify the order of your arch models. So once we try to construct arch, please choose the variable of DLDM multiplied by 100, your original data, right? Sorry about this.
Squared residuals just to identify an arch.
Yeah, identify the orders. If you want to use the squared residuals to identify arch or gauge, you need to perform the ALMA model. Right? See, because the gauge is a ALMA model in the foundation theory, right? Okay. Now we have all the numbers we have. We got the coefficients, alpha 0, alpha 1, and beta 1. All these coefficients are significant. The thing we need to care is about the AIC, your information criteria. The gauge 1.1 is sufficient enough to cover most of financial data. If you construct a gauge 3.3, your model is misspecified. Right? Next step, we run the fundamental statistics with squared residuals. Then there's no autocorrelation in the residuals estimated from our gauge 1.1. Our model is not misspecified. Once we do this,
sorry, I'm trying to ask this question.
yeah.
How do you know if it's based on this information, not arithmetically now? How do you know that there is no autocorrelation?
Yeah.
Looking at this.
Here we go for the last estimation result. This result is for the fundamental statistics. The null hypothesis for fundamental statistics is your data, your time series is follow the residuals estimated from your model. For example, you have identified your AR1 or gauge 1.1. We can estimate the residuals, right? If your model is not misspecified, your residuals or squared residuals should follow IID. It should be a white noise. Right? The null hypothesis is your residuals follow IID and has no autocorrelation. It's a hypothesis. Right? So if we get a significant value in the fundamental test, if your test result is significant, we will reject the null hypothesis. If your squared residual do not follow ID, we assume they have autocorrelation. Right? That's why if you get a significant value, we reject the null hypothesis. Your residual is not a white noise. It has autocorrelation and it does not follow ID. If we fail to reject the null hypothesis, like what we have here, is an insignificant test result. We fail to reject the null hypothesis. Your squared residuals is a white noise. If your squared residual is a white noise, then it has no autocorrelation. Once we've done the autocorrelation test, we need to get rid of all the unnecessary terms. We perform the exclusion restrictions for each of the variables. Exclusion restrictions, beta 1. We need to keep all these variables so our gauge 11 is not misspecified. Once we have a gauge, what we will do next? Remember, there is limitations for gauge model. The first thing, the gauge model cannot capture the leverage effect. Right? Your gauge model cannot give the credit for the concept. In the finance, we know if you have a higher risk, you should be rewarded with higher return. But the gauge model do not capture this concept. So in this case, we will introduce the E-gauge and the JGR gauge. These two gauge model captures the leverage effect. For the E-gauge, they take natural log for the conditional variance. If we take the log for all the parameters in the gauge, so the coefficient can be negative, because even your coefficient is negative, your conditional variance still be positive. Right? It can break the law of non-conditional, non-negative conditions for gauge model. For the GGR, we use the dummy variables here. If we have a negative shock in the market, your dummy variable will equal to 1. So we get a squared residues, or if this negative shock after square is become positive, your conditional variance will increase. Right? For negative news or negative shock in the market, the conditional variance will be high. Right? If it's positive, it will equal to 0. Your conditional variance will be remain the same. Right? It's E-gauge and the JGR gauge. How to build a JGR and the E-gauge? We use the model, gauge models, same variables. Okay. Text box of E-gauge. E-gauge here. Okay. This is our E-gauge. E-gauge 11. The coefficients are for 0, and the EPS minus 1, and the absolute value of EPS minus 1. And the beta 1 is with this equation. All the coefficients is estimated by the E-gauge 11. If you want, you can copy this, you can write this equation down, then you will know the coefficient for each of the parameters. Next step, we need to estimate the JGR gauge. Same stuff, empty the box of E-gauge. Choose the gauge variations. Choose the threshold gauge. This is your JGR gauge. In PC gauge, it's called threshold gauge. Take the box. Again and again. Now we have our JGR gauge here. The thresholds. Unfortunately, we have an insignificant value, but the threshold, remember, is your dummy variable. Right? For the threshold. Final step, we need to estimate the gauge in mean. Why we need to calculate gauge in mean? In finance, higher risk will high risk, high return. But the gauge model cannot capture this concept, so we need to construct gauge in mean. Do the model, formulate gauge in mean, and tick the box of threshold. Choose the HT in mean. This is your gauge mean in mean. H means heteroscedasticities. Right? Click again and again. Now we have our gauge in mean. We have a significant coefficients for the conditional variance. You might ask, what is the form of gauge in mean? Gauge in mean model has two equations, equation 1 and equation 2. Right? For the equation 1, this is your conditional mean, but we have put on conditional variance into the estimation of your conditional mean. Right? Higher risk, your conditional variance t minus 1. The sigma t minus 1 will increase. Your return yt will increase. Right? Decrease in your risk. Decrease in the return. Right? There's no change for the conditional variance. Right? This is called gauge in mean. The coefficients HT is for the coefficients of your risk. Once we have a gauge in mean models, we have done most of the gauge model constructions. And finally, we're gonna make some forecasts. How to make forecasts? Pick your box estimates. Right. We need to reserve some observations for the forecast. Type is 14, estimate 14. These 14 observations will be not used in the estimation of your model. Right? We will pick these 14 observations out of the estimation process. Why is that? I will show you later. 14 estimations. We get our new model. Next step, tick the box forecast. Tap forecast. Okay. Number of forecasts, 14. Because we have reserved 14 observations, so the maximum forecast is maximum number of forecasts is 14, right? Click OK. Now we have our forecast diagram. In this diagram, we can see our forecast is not that accurate because for the blue line is our forecast value. The red line is your actual value. You can see there's a huge forecast error. The green line here is your conditional variance. The range of fluctuations is also quite large. So our forecast is not that accurate. You might ask, how can we compare the forecast error with different models?